Good day, grade 8 mathletes. In this video, we will talk about factoring polynomials by grouping. But before anything else, let's consider this polynomial. 21y squared plus 14y minus 15y minus 10. Recall that the basic in factoring polynomials is to always look for GCF before applying any methods. However, in this case, we can see that the terms have no common factor. Moreover, it's quite obvious that the polynomial is not a difference of two squares, a sum and difference of two cubes, a perfect square trinomial, and a general trinomial of the form ax squared plus minus bx plus minus c. Thus, we cannot apply their patterns to factor this polynomial. This one is an example of a scenario that not all polynomials are factorable. However, sometimes a polynomial has a greatest common factor of 1, but it may still be possible to factor the polynomial by a suitable rearrangement of the terms. And this process is called factoring by grouping. And to factor polynomials using this method, let's make ourselves acquainted with these simple steps. The first step is to group the terms, meaning we're going to collect the terms into groups so that each group has a common factor. And after this, factor within the groups. This means we're going to factor out the common factor in each group. And finally, we're going to factor the entire polynomial. If each group now has a common factor, we're going to factor it out. And if not, try a different grouping. Going back to the example polynomial earlier, let's try factoring 21y squared plus 14y minus 15y minus 10 by grouping. So the first step is we're going to collect the terms into groups so that each group has a common factor. In this polynomial, we can see that 21y squared and 14y have a common factor. The same also with negative 15y and negative 10. This means that we can group 21y squared and 14y as one group and negative 15y and negative 10 as another group. Thus, we have the quantity 21y squared plus 14y plus negative 15y minus 10. In this case, let's observe that the operation between 21y squared and 14y is addition. This gives us clue that the second group must have the same operation as well. Hence, we're going to remove the negative sign, and if we're going to remove the negative sign, that means changing the sign of the terms inside the parentheses by dividing each term by negative. So we have 21y squared plus 14y, and removing the negative sign here, so we have negative times the quantity and negative 15y divided by negative, or simply negative 1. Cancel this out, so we have 15y, and negative 10 divided by negative 1 is equal to, cancel this out, equal to 10. Therefore, we have here negative times the quantity 15y plus 10. Okay, so we have 21y squared plus 14y minus the quantity 15y plus 10. Then, after the terms have been grouped, we're going to factor within the groups, and that's step 2. In this step, we're going to factor out the common factor in each group. So, in the quantity 21 plus 14y, the GCF here is 7y. So removing this GCF means we have to divide each term by 7y. 21y squared divided by 7y is equal to 21 divided by 7, so we have 3, and y squared divided by y is simply y. Recall that when we divide terms, we simply subtract exponents. So we have here 3y, and 14y divided by 7y is equal to 14 divided by 7, we have 2, and y divided by 7, so this will be cancelled out. Therefore, the answer here is 2. So we have here 7y times the quantity 3y plus, and 14y divided by 7y is equal to 2. Then minus, and let's do the same for the second group. The GCF here is 5, and dividing each term by 5, we have, so that means we're going to remove 5 as the common factor and divide each term by 5. So 15y divided by 5, we have 3y, and 10 divided by 5 is equal to 2. Therefore, we have here the quantity 3y plus 2. So the polynomial now becomes 7y times the quantity 3y plus 2 minus 5 times the quantity 3y plus 2. Then, after this step, we're going to proceed to step 3, which is factoring the entire polynomial. That means if each group now has a common factor, we're going to factor it out. If not, then it is suggested to try a different grouping. Fortunately, after grouping the terms and removing their common factor, there is a common factor. As we can see, the quantity 3y plus 2 is common to both groups. So we're going to factor out the quantity 3y plus 2. So we have here the quantity 3y plus 2. And that leaves us 7y here and negative 5. Take note that when we say factor out, we divide the term by the GCF. In this case, we have 7y times the quantity 3y plus 2, and the GCF is 3y plus 2. That means we're going to divide this whole term by 3y plus 2. And 3y plus 2 here over 3y plus 2 will be cancelled out. Thus, we have 7y. And we have here negative 5y, or negative 5 times the quantity 3y plus 2 over 3y plus 2. And this will be cancelled out, and this is equal to negative 5. Okay? So that means the GCF is the quantity 3y plus 2. And removing this GCF, that means dividing each term by the GCF 3y plus 2. And that leaves us with 7y and negative 5 as one of the factors. So we have here the quantity 7y minus 5. Okay? So, to put simply, after removing the GCF, the quantity 3y plus 2, automatically, the other factor is the remaining term, which is 7y and negative 7 and negative 5. So that's the final answer. The quantity 3y plus 2 times the quantity 7y minus 5. Let's have another example. Given the polynomial ab minus c minus ac plus b. Again, the first step is we're going to collect the terms into groups so that each group has a common factor. In this polynomial, we can see that ab and b have a common factor. The same also with negative c and negative ac. This means that we can group AB and B as one group and negative C and negative AC as another group. Thus, we have the quantity AB plus B plus the quantity negative C minus AC. Again, notice that the operation between AB and B is addition. This gives us clue that the second group must have the same operation as well. Hence, we're going to remove the negative sign. And removing the negative sign, we have negative AB plus B. And removing the negative sign here, so we have minus and negative c divided by negative, we have c, and negative ac divided by negative here, so we have plus ac. So all we need to remember is when we remove the negative sign, that changes the sign of the terms inside the parentheses. From negative, it becomes positive, and positive becomes negative. In this case, it happens that both terms are negative. Thus, we have negative c becomes positive c, and negative ac becomes positive ac. Okay? Then, after the terms have been grouped, we're going to factor within the groups. And again, that's step 2. In this step, we're going to factor out the common factor in each group. So, in the quantity AB plus B, the GCF here is B. And dividing each term by B, we have A plus B divided by B is 1. As I explained earlier, removing the GCF means we have to divide each term by the GCF. Thus, AB divided by B is A and B divided by B is 1. And let's do the same for the second group. The GCF here is C. And dividing each term by C, we have, so let's remove C. And C divided by C is 1 plus AC divided by C is A. Therefore, the polynomial becomes B times the quantity A plus 1 minus C times the quantity 1 plus A. Then, after this step, we're going to proceed to step 3, which is factoring the entire polynomial. If each group now has a common factor, we're going to factor it out, and if not, then it is suggested to try a different grouping. Fortunately, after grouping the terms and removing their common factor, there is a common factor. As we can see, the quantity A plus 1 is common to both groups. Recall that addition is commutative. That means the order of the addends does not affect the sum. This means that the quantity 1 plus A can be expressed as the quantity A plus 1. So we have, or we're going to factor out now the quantity A plus 1, and that leaves us B and negative C. So if we're going to factor out the quantity A plus 1. That means dividing each term by the quantity a plus 1. That leaves us b here and negative c here. That means the other factor is automatically this outside terms. So we have b minus c. Therefore, the factors are the quantity a plus 1 times the quantity b minus c. So that's the final answer. Let's have another example. Given the polynomial 2c plus 2d minus cd minus d squared. In solving this example, I'll explain it as briefly as possible since I've already explained the procedures in greater depth using our first and second examples. And if ever you have missed some details, feel free to play back the video. In this polynomial, we can see that 2c and 2d has a common factor. The same also with negative cd and negative d squared. This means that we can group 2c and 2d as one group and negative cd and d squared as another group. Thus, we have 2c plus 2d plus the quantity negative c d minus d squared. And let's remove the negative sign here. So we have 2c plus 2d minus, again, removing the negative sign here changes the sign of the terms inside the parentheses. So we have here cd plus d squared. Then let's factor out the common factor in each group. So in the quantity 2c plus 2d, the GCF is 2. Removing these 2, we have 2c divided by 2, we have c, plus 2d divided by 2, so we have d, minus, while in the second group, the quantity cd plus d squared, the GCF here is d. So let's remove the common factor d and divide each term by d. So we have cd divided by d, we have c, plus d squared divided by d, so we have d. So the polynomial becomes 2 times the quantity c plus d minus d times the quantity c plus d. Then, after this, let's factor the entire polynomial by factoring out the common factor in each group. As we can see, the quantity c plus d is common to both groups. So factoring this out, we have the quantity c plus d. We will have the quantity c plus d, and the other factor are the terms outside the parentheses, which is 2 and negative d. So we have the quantity 2 minus d. So that's the final answer. Quantity c plus d times the quantity 2 minus d. Okay. Using the same polynomial, 2c plus 2d minus cd minus d squared, let's try a different grouping and let's find out if we'll arrive at the same answer. So instead of the quantity 2c plus 2d plus negative cd minus d squared, let's have 2c and negative cd plus negative 2d, and negative d squared. Let me write it here. So we have the quantity 2c minus cd plus 2d minus d squared. In this case, both binomials have the same operations, so there's no need for us to remove a negative sign. All we need to do is remove the GCF-C from the first group. So we have here C, and 2C divided by C, we have 2. And negative CD divided by C is negative D. From the second group, we have, I'm sorry, this is 2D. We have 2D minus D squared. So the GCF here is D. And removing the GCF D, we have 2D divided by D. So we have 2 minus D squared divided by D. So we have D. Thus, we have now C times the quantity 2 minus D plus D times the quantity 2 minus D. And the factors are, automatically, we're going to get the common factor 2 minus D times the quantity C plus D. Okay? So as you can see, we arrived at the same answer. So we have here quantity 2 minus D times the quantity C plus D. Well, you might ask, how can we tell whether we've got the right factors or not? Just simply multiply the two binomials, or you can use the FOIL method. In this case, we have C times, let's see here, we have C plus D times the quantity 2 minus D. And we have C times 2, so we have 2C, and C times negative D, we have negative CD, and D times 2, so we have plus 2D, and then plus, or D times negative D, so we have negative D squared. And we just need to rearrange the terms a little, and presto, we've got the correct factors. So we have here 2C plus 2D minus CD and negative D squared. Okay, so that's for example number 3. Let's have another example. Given the polynomial 7k plus 2k squared minus 6k minus 21. In this polynomial, let's consider first the signs in forming the two binomial factors, so that we'll not be dealing with or manipulating any negative sign anymore. Although 7k and 2k squared and negative 6k and negative 21 each has a common factor. However, the signs of the binomials are different. So let's find another possible group where we don't need to manipulate the signs anymore. And here, we can see that 7k and negative 21 have a common factor. The same also with 2k squared and negative 6k. And the operations within the binomials are the same. Thus, we have the quantity 7k minus 21 plus the quantity 2k squared minus 6k. Then, let's factor out the common factor in each group. So, in the quantity 7k minus 21, the GCF is 7. So, let's remove 7. And we have 7k divided by 7 is k. And negative 21 divided by 7 is negative 3. And let's do the same for the second group. The quantity 2k squared minus 6k, the GCF here is 2k. So let's remove 2k. And that leaves us 2k squared divided by 2k is k. And negative 6k divided by 2k is negative 3. I'm sorry, I forgot to press for the steps. So we are now in step 3. So factor the entire polynomial by factoring out the common factor in each group. And as we can see, the quantity k minus 3 is common to both groups. And factoring this out, we'll have the quantity k minus 3, and automatically the other factor are the terms 7 and 2k. So we have here the times the quantity 7 plus 2k. So that's the final answer. The quantity k minus 3 times the quantity 7 plus 2k. Well, if you have any questions, you may write your comments below, and I'll try to respond to your question after reading them. And let's have the last example. Given the polynomial 10m plus 2n plus 5mk plus nk. So in this polynomial, all the terms are positive. So all we need to do is to collect the terms into groups so that each group has a common factor. And here, we can see that 10m and 2n have a common factor. The same also with 5mk and nk. Thus, we have the quantity 10m plus 2n plus the quantity 5mk plus nk. So we have now the quantity 10m plus 2n plus the quantity 5mk plus nk. Then, let's factor out the common factor in each group. So, in the quantity 10m plus 2, the GCF is 2. So, let's remove the GCF 2 and divide each term by 2. So, we have 10m divided by 2. We have 5m plus 2n divided by 2. We have n. And in the second group, the GCF is k. So we have here plus k, and divide each term by k. 5mk divided by k, we have 5m plus nk divided by k, we have n. So we have now 2 times the quantity 5m plus n plus k times the quantity 5m plus n. Then, after this, let's factor the entire polynomial by factoring out the common factor in each group. As we can see, the quantity 5m plus n is common to both groups. Factoring this out, we'll have the quantity 5m plus n. And the other factor is simply the terms outside the parentheses, which are 2 plus k. So we have the quantity 5m plus n times the quantity 2 plus k. So that's the final answer. Alright, that's all for today's video, and hopefully you learned something from our discussion. See you again on our next video.